We are here at Dan Does Data looking at self-driving car models. And last week, if you recall, we were looking at this data set called DeepDrive that this fellow named Craig had put together based on a Grand Theft Auto 5 data set. That is, he either wrote a script or he literally drove around in Grand Theft Auto for like 80 hours or something, 42 hours of driving, keeping an image of the car the whole time and all the information about the car, what direction, which way the wheel is going, how much you're accelerating, the stuff like that. So I want to try to build a model of that. And last time, and again, this is all for this Power Racing series, Build an Autonomous Car. Last time, you might recall, I was having a problem with the data. My images were looking really strange. I eventually got it to the point where I had something like this. And I was trying to figure out, well, why is this like this? This doesn't make any sense to me. This color isn't really right. One of the viewers pointed out, hey, why is the white lane marking on the edge of the road, why is it black? That's not right. So there was several suggestions about what should be done. Craig, the creator of DeepDrive, wrote to me. Craig, I have to give him full credit, he went out of his way to make sure he reached me. He emailed me, he left a comment, he was very good. He mentioned, hey, this isn't in red, green, blue format, it's in blue, green, red format. That would be the primary problem of that I had wrong. So the green color is red, but what's red here should be blue, and what's blue should be red. So we need to, and he left code everywhere saying, oh, if you do this, you'll be able to read it just fine. So I want to make sure I can do that. And this shouldn't be that bad. We've read in the data that we had last time, and I've just got B here is 909 images of the first one, and they're in this, right now, blue, green, red setup. So we need to futz around with that ordering a little bit, and to do that, we need to move the channels count to the end, and then we'll futz around with the order. We might not, maybe we don't have to actually. We'll move the channels to the end, and I thought I remembered, and I actually screwed up. I've been doing this swap axes thing twice to exchange one axis for another. So move this 3 to like at the end is what I wanted to do. So I say, all right, we'll move this 3 and this 227, but then I need to swap the rows with the height. You can just use transpose to do this, it turns out. You say, let's just look at b of 0 dot shape. That's one image. If you take a look at b of 0, you get the color channels. You can just say dot transpose, and I believe I want the new setup to be 1, 2, 0. So what was the first axis, 0, I want to be at the end. And then I say dot shape, and you see that does basically what I wanted. So if I just say plot dot image show of this, yeah, we get like this weird blue channel. Things are way too blue in this channel, aren't they? But our lane marking is white. So what I believe what we want to do is we want to take that, I want all the rows, all the columns, but I want to reverse the channels, of course. Because this will make what is blue, green, red into red, green, blue. Now tell me, that looks like a much more reasonable image, doesn't it? That's 4 minutes to first success. That's got to be a new record on this channel. Just another case of make sure you look at your data. So you see this is all green, that makes sense. This is yellow, that makes sense. This is white, that looks right. Sky, surprisingly blue. Rather than being really red or really whatever, it's one of the weird things is makes this somewhat difficult for like the human eye to detect is that like human perception doesn't see this much red, this much green, this much blue. There's colors outside this spectrum, A, that your eye can recognize, and B, like depending on the distribution of cones in your eyes, you'll be able to distinguish more or fewer colors in a certain realm. Like I know with greens, I can't distinguish greens nearly as well as I can like reds and blues. So it's not surprising that this is not obvious how to approach the problem. Okay, but that's how we can do this. So let me make sure I get that down. So now I need to actually read in the data properly and do this to it. Let's do it to it. Bam, there we go. I'm not actually going to want to transpose it when I do that though. So let's see if I can change the order of these things. And then transpose. Does this even make sense? Right, because the Keras is expecting channels, then rows, then height. I don't know why I'm highlighting things for that. That doesn't really help make that clear. Transpose 1, 2, 0. One more parentheses. Yes, that does work. Okay, that's the same image. Huzzah, life's good. And in fact, let's do that way. Do that, just so it's clear, and we don't need to invert anymore, right? No, inverting was never the right thing. It looked like almost the right thing, but it was not the right thing. And all the rows and all the columns, right? So just so anyone who's new, this : -1 says reverse the order of these things. The way that really works is everything before the first colon says, hey, start at this number. You don't say anything, start at the beginning. Everything after the first colon says, hey, go up to, but not including this number. If you don't put anything, it goes to the end. And after the second colon tells you how many to step by in between each element. So the -1 says, hey, step backwards 1. And so that's how that's going to work out. So this just reverses the order is all. And because we're using the array notation, we've got these other colons here. Just say, hey, grab all the rows, grab all the columns. Stick them in this format. All right, so I don't need to keep this blue channel inverted baloney anymore. That's right, I was trying to resize the images. Interesting. All right, let me just remake B here. B equals B.transpose. B of, I want all the data points. I want to reverse the order of, I want to get red, green, blue. All the rows, all the columns. And I want transpose, and I do want the first one there. And then 2, 3, 1. Right? So leave the data points in their correct order, and then shift around the images. Oh, maybe I don't want to transpose. No, that's right, I don't want to transpose. There we go. Let's do that. B.shape, yep, there we go. So now you can do image resizing kind of things. See if that makes sense. Yeah, so now I've resized it to 128 by 128. Whereas it started 227 by 227. Whereas when I do this, that's the blue business, right? So I don't even need that anymore. I do want to see, so we're going to be getting to some modeling today, as always, but we do have to, I would like to explore the data set a little bit more. Namely to see how small I can get away with this making any sense. So like you kind of look at this, you can obviously make out where the road is, but you can't really make a good sense of this oncoming truck when you're at 64 by 64. But that truck's a ways off, so I want to kind of minimize my data size to start out with. I should just nuke this inverted color stuff since that was all wrong. There we go. Slim down the inputs, yes. Alright, so I want to read in this data. In addition to the image data, we've got other stuff. A.keys. vehicle states and targets, and I had sorted out what those were. There we go. There we go. Vehicle states. That is your whatever your vehicle is doing at the previous time. Dot items. Is that what I want? Data set has no attribute items. No, of course not. Dot value. That's what I want. Ding. Okay. There's this 6-long array of things, and now I just try to remember what those things are. Data set. And Craig was super awesome. He updated his README. As you can see, updated, not upgraded. I don't think of it as like an upgrade. On July 27, which is super good. So if you go to deepdrive.io, scroll down about halfway, you can download his dataset. That might be how Craig found me. I don't know, because I downloaded his dataset. And yes, now he's added, this is how you can look at the image. But this is what the data points are, in addition to the images. We were interested in the direction. No, not the direction. That's the direction the car is spinning, I think. No, maybe that's spin. We're interested in the speed, the acceleration, the speed change, the gas, and the steering. Those are the things we really want to know. Speed and acceleration are really just going to be inputs. Our outputs really are the gas and the steering. It's kind of cheating to use those as the inputs and the outputs, even though you'll be predicting the next time step. That's not cheating. But to start, I just want to work with these things. Direction, one for left spin, one for right spin. Oh, the direction of which way you're spinning, whether you're clockwise or counterclockwise. Right. Okay, so this 3 and 4 are the things. 3, 4, 5, and 6 are really what we want to extract. Well, it's 3 and 4 from the current time step, and you want to know what's the throttle and the steering for the next time step. That's really what you want. And that's why he's got this dot value, and that's why he's got the vehicle states and the target, even though it's duplicated information. And I can demonstrate that. Targets. Yeah. You see the first target is the second time step, the second vehicle state. And if you say everything but the last, let's see, you start at the first vehicle state, the second vehicle state, and I ask if this equals all but the last target, you're going to see that's true all the time. And I can say, hey, is false in this thing? And the answer is no. It is never in that thing. This is true everywhere. But for convenience, we already have state and target split out. When we're up against the wall as far as loading in all this data, yes, we're just going to load that in once. And honestly, most of the space of the data is taken up by the images anyway, which we saved big by converting down to 1-byte formats, or 3-byte format per pixel, instead of 12 bytes. So you save like a factor of 4, so you get a 75% cut down, which is nice. This, yeah, you could cut out half of it, but this just isn't that much of the data anyway, so it doesn't matter. Alright, so we can resize the images. That's something I think I would like to do. I'm not going to be like walking, well, I do want to walk through. So this is my old data for reading in some HDF5 stuff. I do have, I'm going to have multiple D files, right? So I'm going to have to do this stuff again. So for a given D file, what are we doing? Question from the audience. What about the network output, a target vector? There's a small bit of code to make target vector wheel position plus break Excel position. I'm not sure what your, the output of this model will be several different numbers, such as the steering and your throttle. If you're saying combine those into one number, being the vector that you want to go, That sort of makes sense. It is like a magnitude in this direction, but you still need two numbers to describe that either way. So that sort of changes what space you're working in, but that's technically going to be the same information. But you're right, that's a good way to think about it. And if I really wanted to get down into the physics, which I've done quite a bit at university, that might be a good way to think about it. If I model this on paper, that is 100% what I do. I want to have this vector output, this velocity, sort of. Well, but it's force, it's other things too. So I'm opening up the file here. Label list is not really, see, I gotta sort out what are the old things that I'm dealing with. It's HF5, that's old. There we go. I don't need to view the image anymore. I don't think I need that. I don't think I need that. I make the A, where did I make the B? There we go. Let's grab B. Thinking too practical in the chat? No, practical is good. That might be the thing that makes sense. Like, oh yeah, we should do it that way. I'm of the mind that I'm going to try the first thing that comes to mind. And then we can think about other ways to manipulate it. Oh, try this, try that. As far as the machine learning is concerned, it's sort of agnostic about those details. All right, so this is raw image input. No, raw data. Extract images in compressed in 1 byte format. 1 byte format. Just leaving myself comments so I can remember what the heck I did next week. Change blue, green, red to red, green, blue. There we go. And I wanted to resize, just because I can. Oh, is there a fast way to resize? Or to resize all of them? Array the image to be resized, inflow tuple, interpolation. I don't think so. That's a bummer. I guess I could say images equals numpy.array, numpy.zeros, and it's however many things I got. So the first dimension of B and the data type equals, hang on. Image size equals 64. I want 64 by 64 images, just for the giggles. We got 3 channels, 64, 64. And D type is numpy.uint8. Unsigned bytes. Too many there. There we go. And then I can say for I comma B in enumerate B images I equals this thing. There we go. For the moment, I only have one D file, so to do handle multiple HDF5 files. High density file format 5 files. I was saying file too many times. Need to expand data or batch process. Or batch process fitting. One file at a time. So we might put our model fitting inside this loop, which isn't the end of the world. Maybe I'd really want to just store my compressed data here. I don't know. that can go a lot of ways. So those are our images. What do I want not my other inputs, do I want to just call them inputs? Input data? Inputs? That sounds so dumb. What are they? Speeds? Speed X? Speed X for speed and speed difference. If it's speed and acceleration, alright, that's fine, speed X. This is A of vehicle states dot value, and I'm gonna want, question is what is the state? What is the data type of that? Is what I need to say. Dot value, because it's probably like float 64 or something. Dot d type. Float 32. Yeah, all right. I'm just gonna make that float 16, to be honest. I'm not particular about it. Maybe not. Maybe not. Some of these are actually close to 0. All right, float 32 it is. Doesn't make a big difference anyway. So that could just be that, except I want all the data points, and I just want column 0, column 1, 2, and 3. So 2 up to 4, but not all the others. Targets can equal, we'll say targets. If it's gonna be convenient data, I'll use the convenient data. All the rows 4 to the end, right? Because I want, oh, hang on. Yes. 0, 1, 2, 3, 4. So throttle and steering, which is just a bunch of positions. And I guess throttle position goes from 0 to 1. That's what it says. I would like to check if that's true. Everything and 4. Yeah, there's definitely negatives here. Yeah, up to negative something. So that's the braking. Must be built into that. So if I just say plot.plot. Yeah. Down to -1 up to like positive 0.6. I guess it was never, in this particular data set, never happened to be going all the way above. And you can sort of see that this is actually quantized on some level. Probably not at the 32-bit level too. You can see it's constant, it goes up by these little steps, which is interesting. Okay. So those are going to be our targets. And really that's like the targets for this particular chunk of the data. For every font, a bunch of other stuff that I'm not too worried about yet. Alright, so we're resizing the data. We write all this stuff. So let's try this. Auto indent. And let's try reading in all our data. Oh, I didn't like that. Could not broadcast from shape whatever into shape whatever. Because B has into shape whatever. I thought B had the appropriate shape. Images 0.shape. Interesting. Oh, hang on. This might do something funky. Yep. So SciPy.miss.image resize does the weird thing. It's kind of irritating. So I got to transpose that output. Because I want 0, 1, 2. No. 2, 0, 1. Right? I got to stick the channel back at the beginning. It was at the end, now it's at the beginning. That should be fine now. Oh, I should have put her. That was close. I almost lost my cool. It was taking too long. That few seconds makes a difference. So targets is a thing. Speed X is my speed and my acceleration, basically. Two things I can measure. This is going to be my. Oh gosh, the first one's gas pedal. The other one is the steering position, right? Yeah. And we got images, of course, as well. Our actual images. Images.shape. All our data points. Targets.shape. That's what we want to model to. And speedx.shape. Okay. And rows and cols. So let me update this stuff. Reel in. I've got two things in, really. Frame in. That's correct. Yeah, we can do some convolution. Sure, that's cool. We'll flatten. We got flat. We got reel in. Mean squared error, because we're just doing real valued things on the throttle and the steering. We are limiting, our input values are limited between plus and minus 1 in both situations. So that could be trouble. Our outputs are truly restricted. But like, what happens when I predict my steering, I want it to be 2? Then you run into a problem. Right now, I'm choosing to not worry about it. Output is A and P. The angle, A, and P, no. Oh gosh. I should not call these things A and P. A cell and phi. That's what they're going to be called now. That's, let there be no confusion. Or like a cell and steer. Yeah. I mean, I'm not using proper angles and radians anyway. Okay. So this model should be approximately reasonable. And by reasonable, I mean it shouldn't crash in my face. So I no longer need to create fake data. Let's comment out all those guys. So instead of fake real, I've got speed X. Instead of fake frame, I've got images. Instead of, oh, I should have had two outputs. Okay, that's fine. I've got, oh, I gotta remember what it's called. Targets, of course. Of course, that's what it's called. Targets of all the data points in the first column. Targets of all the data points in the second column. And that's what we want. We'll use batch size 32, we'll do up to 10 epochs, and I want to get verbose, yes. See what this happens. Error checking model, right, I've got 3 channels of input, not 1. So let me rebuild the model. We don't need to rebuild those things, just a convolution. There we go. Right, this was set up for like grayscale images, but in fact we have a color image that's set up correctly now. So we can take advantage of those colors. And I am doing that. Yes, this is where I change the color. Resize. Just scale down image size. Speed in the cell, and this is throttle and steering. There we go. Array with shape, but that's not true. You don't have that shape anymore. Did it not do this correctly? model.summary. That's not true. Oh, frame in. That's the problem. Yep. That's the problem. I see. This is where I need 3 inputs. This is how many neurons I want here. Right. So you could have like 1 neuron. You're extracting 1 convolutional feature. Or maybe I'm extracting like 4. Just for giggles. Let's suppose that's what we have. That was my mistake. I shouldn't have had 1 there, actually, ever. Really, I think. I guess I was trying to build like, the simplest possible linear model, but yeah, so maybe 1 neuron makes sense in that case. N samples. This should really be, I have 999 samples. Big money, big rocket, go now. So instead of being 16 by 16, and it's now 64 by 64. Granted, I only have 2 inputs and 2 outputs instead of like 4 inputs and 4 outputs, but you know, or 4 inputs and 2 outputs. So I saved a couple things there. Look at that. Boom, boom, boom. All right. And it's given me some accuracies, but we're not doing a classification problem. So you can't just say, oh, clearly that's, 87% accurate or whatever. That gives you an obvious measure. Let me actually increase this. Oop. Let's do 100 epics just for fun. Although this seems to be stuck now, which is maybe good and bad. Okay, it's not going anywhere. That's fine. That's fine. H dot history. So these are the various outputs. I'm guessing. Let's say model.summary. Something I don't like about Keras, the way it names these. I'm not a super big fan of, but I appreciate that it is. These are unique. I believe this is going to be my first output and this is my second output. I don't know that for sure, but I believe that to be the case. All right, model dot get weights. There we go. That's always what I want. And we got some weights. We're only halfway through. Not half bad, eh? Alright, so what is W? W0. This should be some convolutional stuff? Yeah. These are our 4 convolutional features on 3 colors, and they're 3x3 convolutions. What is W1? Those are the 4 bias terms in our convolutional filters. I wasn't sure what order these were going to occur in. 4096, 1. Oh, 4098, excuse me. So after flattening the convolutional output, you get 4096 things, plus 2 more features, these guys. I assume those are going to be at the end because they come after. So it's the flattened stuff from the convolution, then the real stuff. And you get one of those for the acceleration, and you get one of those for the steering. This is probably going to be 1 bias term, yep, for the acceleration. These are my 4098 coefficients to compute the steering, and I should have 1 bias term on steering. And I really hope W5 is like 0. I don't necessarily want to be biased to turning left or right. Okay, so we're a little biased to turning right. But depending which way you're going around the track, maybe that's what you want, you know? That's funny. That's real funny. For example, oh, that's interesting. So actually, let's take a quick look at these guys. Yes, something you should note. You've got like all the convolutional features you could ever want. Then you notice this huge spike at the end because our real input, the acceleration that we currently have, hey, that's kind of important. And I believe all these are scaled. They might not all be scaled the same. But the speed change should be on a similar scale as the speed. Smaller, if anything, I should think. Because your speed from one frame to the next is probably going to be pretty close to 0, which is why this is huge, actually. Because if your speed change is usually 0, this coefficient will have to be that much larger to make up for it. So that doesn't actually tell you that much in and of itself. But W0 though. I have to look at the shape every time to see what I'm doing. Okay. Let me open up thought I had a CNN model in here. var data in. What this? Did I not look? There we go. This is the kind of thing I want. Ugh. I don't actually want to do that. W. There we go. All right, what am I doing here? I wanted to just take a look at some of these weights and say, oh, for this color, for that color, for this other color, what do we even get here? So I think what I need, I want I want 4 rows of 3 rows each of subplots. So I need 9 subplots. 4 rows, 3. Each one of these subplots is going to be 3 by 3. And then I'll see the red, the green, the blue, how those colors matter. I could actually do a single. I could jam all those together and just plot the image created by that red, green, blue. That might be kind of interesting. Let's do this. Let's do this first though. For I in range 4, row, and for col in range 3, f comma con. Yeah, what is con now? Con.shape. Yeah, there we go. Row comma col. There we go. Dot p color mesh. W1 row. Col. That's the easiest thing. Let me just kill this temporarily. This should do what I want. That didn't do what I want. Must be integers or slices, not tuple. Oh, nope. 0. Row col. That should be more about what I want. W0, comma row, comma col. Let's see what we get. No, what's col? W0. That's shape. That's weird. W0, comma 0? What? W is not a array? Or W0 isn't. Right. W0 is not. W is not an array. W is a list. Type of W0, however, that's an array. One of those things. Tripping me up. Okay. So I don't expect these images to be super enlightening because we have very few of them. And I'm trying to like combine the red, green, blue and look at it at once, and that ain't gonna work very well. But you might expect to see something in here. All right, but that's just interesting that that works at all. What about model.predict? I gotta dump an image in. All right, what if I say images 0, targets 0. Model.predict, and I gotta put in what? X, the input data, as a numpy array. Well, that ain't gonna work. Or list of numpy arrays, yes. If the model has multiple outputs, I believe you mean inputs, right here. So a list of numpy arrays, speed x 0, comma images 0. Error when checking. Expected input 2 to have 4 dimensions, but got array with shape such and such. Oh, you're supposed to predict multiple things. Alright. Go to the first guy there. Go to the first guy there. And that's what you get as the output. When in fact, you wanted something like this. So that's just one spot check. That doesn't mean anything. But this tells you, well, we wanted to turn halfway to the right. We're turning a quarter to the right. I wanted to break a little bit, and I'm breaking less than a little bit. You know, I'm breaking 1/5 as much as I really want to. And turning to the right, not as much as I want to. But again, super simple model, just a little bit of training. Not very much data. But that was really the goal, just to be able to have a model that runs at all. And that's what we have. So we can high five ourselves on that count. And we can look at the output a little bit. I do want to look at the actual output image as though it is red, green, blue. Let me think about this. And I've got look at con filters separately in color. And then I want to combine color channels into one filter each. Right, because I might see something interesting, like there might be an image of a cactus, for example. Not that you're going to see that in a 3x3 image. But that could be something that you would see. But I don't want plot.pcolor mesh. I want plot.image show. And what does row tell me? That's which feature I'm on. Can I get away with this? I probably can't. It probably wants this in another order. What in sauce am I doing? Like, I did not think this was going to bleed into each other like this. That's weird. Like, clearly this is giving me a 3x3 grid, right? But these are super weird shapes to be doing it on. Can I say don't try to squish it? Shape an NM, NM, comma 3, or NM, comma 4. Oh, hang on. I probably can't get away with what I tried to do. Yup, that's part of the problem. That is part of the problem. Transpose. I want to move the beginning to the end. This is why I should not have used a 3x3 filter size. Right? It's just a good way to go crazy, is what it really is. So this is 1, 2, 0. Because I want to move whatever's the beginning, then we're channels to the end. That didn't seem to work at all. Yeah, well. Let's try that. I'm missing a parentheses, I think. The danger of doing things live, as always. There we go. Much better. But again, it's squishing these images down, so it's not super obvious to me what's actually going on. Like, there's clearly a yellow dot in the middle, a couple of white dots here. I want to get a true fidelity on that image. How can I say don't squish it? Default none. If none, defaults to image.rc.image aspect value. Interpolation. Default none. Filter norm, filter add. If interpolation is none. Alright. So maybe that's what I want. Whoop. Maybe I need interpolation equals none, which is different from passing in none, apparently. Let's try that. There we go. Oh, well. Hey, there we go. Yes, so that's what I wanted to see. These actual images. Why it's getting goofy about that. The aspect ratio is kind of strange, but that's okay. So obviously these don't look like anything in particular. The convolutions are pretty small. In 3x3 I wouldn't expect to see anything in particular across these three channels, but you might just start to see like the shape of something. Might make sense. Let's actually... Let me do something. Let me make a much bigger convolutional filter and retrain it. Like, I don't know, an 8x8 image. 8x8 convolution, say. And rebuild the model. Just to see what happens. Just to see. And maybe then we'll see something when we train it for 100 epics or whatever. Maybe. We don't know. It's got to recompile. It takes forever. It yells at me. Doesn't like something. Following error happened while compiling. So maybe it doesn't like convolutions that big. Maybe you can't hold that in memory. Let's try 5. That is a total baloney excuse. Let's just redo this. I don't know why it would yell at me about that. And like, these are the errors that it should catch at compile time. But compile doesn't actually do anything anymore. Like, it just tells the model, oh yeah, get ready to do this, that, or the other thing. Okay, so it's computing. Our accuracy's changing, getting worse here? Better, worse, better, worse, worse, worse. Loss is totally getting better. So that's something, I guess. The accuracy is probably converging. Yeah. Okay, so this is converged, essentially, to whatever this model is going to do. So I definitely don't need 100 epics. Grab some weights. Look at separate color channels. Now they're 5x5, as you can tell, in the different color grids. And don't be deceived. Just got to make things squares. There we go. Again, I don't see any super obvious shapes in these patterns. But that's just the way it is. Again, we did not train very long. It is not a super good model. But it is a basic model that is training, that is taking in inputs of our frames, or of frames of video of what the car is seeing. Again, yes, things like this, except in the correct colors. Things like this. This is what you'd see at the front of your car. Like, okay, you don't see your hood, but you can strap a camera to the front of the car. That's just as good. And actual information that the car is doing, things that you would know. You're like, I can look at my speedometer. I'm going such and such fast, and you can tell. Well, you probably don't have, as a human being, it's hard to tell what your acceleration is, per se. You can sort of feel the change in acceleration, but you have some measure of this. At very least, you can put an accelerometer on your car, and you can know that information. So this large delta speed means you're in the process of speeding up right now, which that will change very much whether in the next step I want to hit the brake or I want to hit the gas. And for example, in this step, you're doing almost nothing. You're going like 0, and you can see like our speed hasn't changed much. So if you just recorded the speed, you could get information like this. In fact, I imagine that's almost exactly what they did here. Is this number just this number minus this number? Let's find out. Because we might be able to compress this data set quite a bit. You say, that's not really the same. You know what, you're right. That is not the same number. Hang on. There we go. So that's not exactly the same number. But is it the other way around? I think it might be this minus this. The next speed minus the current speed equals the current acceleration? No, that's not the case. Interesting. Okay, I'm not sure how. Maybe that's some true acceleration difference. Speed change in the above value. That's what it says. Negative velocity. All right, well, whatever. All right, I think that's all we're going to do for today. We built a simple model. We looked at some cool pictures. And we actually read in the DeepDrive data, and we started building a simple self-driving car model based on DeepDrive, based on driving around in Grand Theft Auto. One thing I haven't looked at is this video footage in Grand Theft Auto of someone trying to drive correctly? Or is it typical video footage from Grand Theft Auto where someone drives like a maniac? Because I've definitely done that in the game. So we're going to train a neural network to drive like a human being, but is it a good person or is it a terrible driver? That'll be part of the problem. Okay, that's all I got for this week. Once again, I've forgotten to hit the button on Reddit, so they'll get the information now. Oh well. And that's all I got for tonight. Again, I'll see you guys next week, and stay safe in the data mines.